In this video, we're going to look at testing the difference between two means if we have paired samples. And paired samples means that there's a direct connection between the individuals in the first data set and the individuals in the second data set. So our example is going to be Chief Aru and 5 of our friends, right? So there's going to be 6 people used. We're going to undergo a training regimen that's going to claim to improve their 10K times by more than 5 minutes in only 6 months. So she, being a data person, she's going to record their 10K times, measured in minutes, before and at the end, so after our 6 months of training. That data is going to look like this. All right, so Chief Aru went from 56 minutes to 59 minutes. Other people went from 71 to 62, 43 to 39, 51 to 50, 65 to 56, and 82 minutes to 62 minutes over our 6-month span. So how can she use these samples to see whether or not the training succeeded? And I want to point out the fact, right, this is the reason that it's a paired sample. There is one individual that we're measuring before and after. So it's not really the exact numbers that we're after, but we're looking to see how it changes from the before to the after. All right, so as I said, we're looking at 6 people's performance at 2 times. So we're really interested in these changes. So what we're going to do is we're going to calculate something else. We're going to calculate the difference, right? The new time, right? New, minus the old time, old. And then we're going to look at the difference. So Chief Aru's time went from 56 minutes to 59 minutes. So her time went up by 3 minutes. Up is going to be positive. B went from 71 to 62, so she went down by 9 minutes, down by 4 minutes, 51 to 50, down by 1 minute, 65 to 56, down by 9 minutes, 82 minutes to 62 minutes, so down by 20 minutes. So in this case, a negative value is going to be their time improved. And the data that we're going to do a hypothesis test on is our difference data. Right? This is the thing that we're going to do our hypothesis test on. And quick refresher on hypothesis test. We have null, alternative hypotheses. We have our level of significance. We have our p-value. And if our p-value is less than alpha, we will reject the null hypothesis and switch over to the alternative hypothesis. If the p-value is larger than alpha, we will fail to reject the null hypothesis. It will still be reasonable. And then state a conclusion based on our findings. All right, in comparing our two means, mu1 is going to be our new 10K times. Mu2 is going to be the old 10K times. All right, we really want to compare the differences. So mu d, the difference of the means, is going to be mu1 minus mu2. This is going to echo the calculation that I just made. Our null hypothesis is going to be some claim about the specific value of this difference. Right? So this is entirely analogous to the first time we saw hypothesis testing. That mu d is going to be some specific value. It's going to be 5 minutes in our case. Our alternative hypotheses, again, come in 3 types. That the difference of the means is going to be less than our claim. That's going to be a left-tailed test. The arrow points to the left. The difference of the means is going to be greater than our claim. That's going to be a right-tailed test. Or the difference of the means is simply just not going to be our claim. And that is, of course, our familiar 2-tailed test. Right? In Chief Aru's example, we're checking this claim that the training reduces time, right, that's negative, by more than 5 minutes. Okay? So if it reduced it by 5 minutes, then our difference would be -5. And reducing by more than 5 minutes means that the difference is going to be more negative than -5, right? -6, -7, -8. So that's going to be less than -5 minutes. So our null and alternative hypotheses are going to look as follows. The null hypothesis is that it is going to be reduced by 5 minutes. So mu d is equal to -5. The alternative hypothesis is that we have a reduction of more than 5 minutes, right? So it's going to be -6, -7, -8, and so that's going to be less than -5. Mu d is less than -5. And let's use the alpha of 0.05 as our significance level. It seems to be reasonable for this case. Right? Again, we live in the future. We don't want to do any of this by hand, so this is TI-84. What I've done is I've inputted the data into list 1, and the key is I've inputted the difference data, the +3, the -9, the -1, the -9, right, all the way down to the -20. So that's going to be the data in list 1, and so I want to look at the input as data in this case. As for the rest of it, our mu naught was -5, right? There's the claim that it decreased by exactly 5 minutes. We're using list L1 because that's where I put my difference data. My frequency equals 1. Oops. And mu is going to be less than mu naught, is going to be my alternative hypothesis, right? More than 5 minutes lost, -6, -7, is that it's less than. Right? We hit calculate, and the output's going to look like a t-test, mu less than -5. Boy, I got a lot of typos today. The t is -0.5092, right? Again, that's the statistic on the student's t distribution, right? T being 0 in the middle, so -0.5 is going to be somewhere over here to the left. The area is going to be our p-value. And the p-value in this case is 0.3161. That's going to be our p-value. That's the probability that, assuming the true mean difference is 5 minutes lost, the probability that we get data as extreme as we got. The next things actually tell us our data. The actual mean time that we lost was 6.66 minutes. Right? That's the mean of our sample differences. Our standard deviation of our sample differences was 8.0166, right? Standard deviation of our sample differences. And so our hypothesis test of that, the true difference is 5 minutes. The alternative hypothesis is that it is less than 5 minutes, right? More extreme, at an alpha of 0.05. 0.3161 is greater than 0.05. So that means we will fail to reject the null hypothesis. The null hypothesis is on the reasonable side, and so we can't claim the alternative hypothesis is absolutely correct. So our conclusion is going to be there is not sufficient evidence to show that the training regimen improves 10K times by more than 5 minutes.